Hi, good evening, and good evening. All right, so what's up, guys? What's going on? Well, I got a question from Oman, from a photographer named Imran Zahid. He is a very nice photographer and he's created some really nice content. Do check out his YouTube channel, Imran Zahid. He asked me a question, and he actually the question was kind of a long, and I was like, okay, the question was, what if we use a crop sensor lens on a full frame body, so the output which will come from the uh, full frame body is going to be a crop image based on once you put a crop sensor lens. So will the output will be which will be a crop sensor equivalent, will it be behave exactly like the crop sensor, like it means that does it has to do anything with the quality of the image? And I thought, okay, let me explain you, which I did briefly, but I thought it's a very good question to make a video about. So I thought, okay, let me start like making a video. But before that, I thought, okay, let me explain you the uh, background, why it's why we are making this video. So before I jump into that, let me give you a quick heads up. And the heads up is, before I conclude, before I answer this question, you need to understand a term called crop factor. Crop factor. Yep, you have to understand this thing. Crop factor. Why? Because it will explain you have by understanding the crop factor, you will able to understand the depth of the technical depth of the scenario of the question, and then it will be much easier for you to understand what I'm trying to say. So let's jump in crop factor. So we have Nikon, Sony, Canon, all these camera companies. They have their associated crop factor based on the type of sensor they are making. First of all, like Nikon and Sony, uh, whatever they are making, their crop sensor cameras basically are available with a crop factor of 1.5. All right. Canon, on other hand, they have the crop factor of 1.6. All right. So what it has to do, it will affect a lot. Okay, let me explain you. Um, let's start with Sony slash Nikon. Okay, so they make the sensor, and I'm going to start with the full frame. The full frame sensor, all right, it is 36 millimeter by 24 millimeter. All right, simple as that. So 36 by 24. So once you scale down by 1.5 times, so with the factor of 1.5, the resultant APS-C sensor is going to be, let's jump into that. 36 divided by 1.5, that is equal to 24, and 24 millimeter divided by 1.5, that's equal to 16 millimeter. So it means that the resultant uh, wait a second, the resultant sensor is 26 millimeter by 16 millimeter. So that's crop sensor. All right. So far so good. So once we go for Canon, uh, Canon, wait, 36 divided by 1.6, and then 24 divided by 1.6. Let's do a quick math. Wait a second. I have to calculate. My maths is not good. All right. Okay. So we have 36 divided by 1.6. That's 22.5 millimeter, and 24 divided by 1.6. So that's 15 millimeters. So Canon APS-C or let's say crop sensor is 22.5 by 15 millimeter. Okay, so that's it. That's simple. That's how we calculate the crop factor. That's from where exactly the crop factor terms comes. So far so good, but wait, we are not finished yet. The next step is the crop factor, which is affecting the output, which you need to understand. It's very important. Like I said, these crop factor, which I'm going to highlight you in red, these crop factors are basically very important. As I explained you in this so far, that full frame is basically for 1.5 times, wait, so for 1.5, which is for applies for Sony and Nikon, so we are going to have this, okay, like 36 by 24 will be scaled down by 1.5, will gives you uh, 24, actually, sorry, this is 24 not 26, 24 by 16 millimeter. Okay, so that that it is 24 by 16 millimeter, and same goes for Canon, which 1.6 times. So 1.6 factor is basically multiply over here and over here. Okay, same goes for 1.5 factor for Nikon and Sony, which is applied for over here on the width side and over here on the length side. So now you know how it goes. So this is where things are going to be interesting. So for there, we have to drive two numbers, which you are going to see are going to be used in further in a calculation which I'm going to show you. So for Nikon, Sony, we are going to have factor of 1.5 multiplied by 1.5, which is equal to 2.25. So keep that in mind. For Canon, we are going to have 1.6 multiplied by 1.6 because width and length. So that's why I'm multiplying 1.6 by 1.6 and 1.5 by 1.5, width by length. So because the multiplication factor is affecting the both width and the length of the sensor, so that's why we are multiplying them. So that is equal to 2.56. So now keep that two number in mind, which is this 2.25 and 2.56. Just keep that two number in mind. So now let's step next how these two numbers, which are 2.25 and 2.56, going to affect the calculation, and these calculation will going to answer the question which was asked, that if I'm going to use the crop sensor lens on a full frame, will it going to, the output of the full frame will turn out to be a crop sensor like, or it's going to be still going to be like full frame. That's what we are going to explore now. So now you understand these two terms, 2.25 and 2.56. Done. Now we're going to step next. And I explained this thing in my previous videos, that how the full frame equivalent is to crop sensor and how it's going to affect, but I'm going to explain briefly again in this video. So imagine you have a full frame camera, all right? You have full frame camera, okay? This is your full frame camera. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. It is 12 megapixel full frame camera. Alright, done. Okay, so we are going to use that 12 megapixel and we are going to divide it with this 2.25, because we are using Nikon or Sony sensor, which are mostly used. For Canon, you can easily calculate with but just wait. You can apply the same for Canon and you can calculate the number of pixels, but I'm just using Nikon and Sony because both are having the same multiplication factor, crop factor, which is 1.5. So 1.5 multiplied by 1.5 gives you 2.25. All right. So okay. So What I'm going to do next is this. As I'm going to scale down by 1.5, so I'm expecting the crop sensor will be like this, which is marked in yellow, right? Which is marked in yellow. So basically, this yellow part is your crop sensor, right? So far so good. But how many pixels I am going to get from that crop sensor area? This is what we are going to calculate. So 12 megapixel divided by 2.25. Remember this factor? Yep, we are going to use this factor. And this will give me 5 megapixel, nearly 5 megapixel. So if I'm going to have a full frame camera, all right, which is 12 megapixel, for example, Sony A7S, Sony A7S2, Sony A7S3, or Nikon D3, D3S, or Nikon D700. So we are having 6 cameras in total, which are 12 megapixel, and they are all full frame. So if you are going to put a crop sensor, and they are all 6 of these cameras are very good in low light. They are excellent in low light. So when you are going to use a crop sensor lens on this full frame 12 megapixel camera, you are going to have 5 megapixel crop image. That's it. But the quality of these 5 megapixel image is going to be excellento. Yep, it's going to be excellent low light. Yes, sir. So because you are using the only middle part of that frame, only middle part of that full frame, which, and because the 12 megapixel are having bigger pixel size, which is uh, 8.4 micron meter, and this is a very big pixel, so it captures a lot of light. So the size of the pixel is not changing. You are basically just using the middle portion of the sensor by using the crop sensor lens on a full frame 12 megapixel camera. So basically the light which is projecting from the crop sensor lens over a full frame is always already limited. So let me show you. If this is a full frame lens, so the light projected, first of all, wait. I need to first draw how the full frame lens projected the light. So full frame lens projected the light like this. So the sensor which you are going to get is like this, full frame. So these lights are basically rejected. This is all rejected. Alright. So you are getting 36 millimeter and 24 millimeter, which is full frame. So basically the circle of projection of light from a full frame lens, it's so big that it covers the whole edge to edge circle, edge to edge sensor. So you don't see any vignetting. That's it. But if we are going to use that same full frame sensor, which is 36 millimeter by 24 millimeter, and we are going to use a crop sensor lens. So you know what, let me wait. Okay, so I'm using now a crop sensor lens over a full frame. So the the projection that you will get is like this. So basically this part, this part will be all, you are getting heavy vignetting. So the resultant full frame, wait, so the resultant, wait, uh, lens, the uh, the image that you are going to get from by using a crop sensor lens over full frame will be like this. So this is what you get. This is what you get. These red will be the portion of the full frame that you will get, and which is equal to 24 millimeter by 16 millimeter. That's how it is. So you are basically cutting down the portion of the full frame by using a crop sensor lens. So now imagine you are having Now you are having a 12 megapixel full frame camera, which is excellent for low light. Excellent for low light. So you are going to get 5 megapixel in crop mode. So those 5 megapixel will exactly behave like full frame because it's the part of the full frame. You are using only the middle portion of the full frame. So lens doesn't have anything to do with the sensor output. It's just basically projecting this limited portion because its lens is designed for the smaller portion. So the light coming out from the lens is already small. The circle of light, circle of projection already small. So it will not going to cover edge to edge. It will never going to cover this edge. Nope, 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 nope. It only going to cover the middle portion, and out of from middle portion, which is this, you're only going to get 5 megapixel if you are using 12 megapixel camera. Now imagine you are using 24 megapixel full frame. So let's do something. So wait, you are using 24 megapixel full frame camera. So divided by 2.25, this will give you 10 megapixel approximately. Alright. So if you are using a 24 megapixel excellent camera like D750, 780, Z6, Z62, or your D610, D600, or A7, A72, A73, yeah, or Panasonic S1. All these cameras are 24 megapixel. So you are going to get only 10 megapixel if you are going to use a crop sensor lens on those 24 megapixel camera. Now imagine you are having, wait, now you are having 36 megapixel camera, which is D800, D800E. So which is like D800 or D800E or D810. These are all 36 megapixels, so divided by 2.25, which will give 16 megapixel in crop sensor. You will get 16 megapixel crop sensor. So far so good. Now move forward. You have 45 megapixel camera divided by 2.25. There is of course D850. This will give you 20.9. So this is basically D500 or Z. Wait. Basically you will get not only D, you also get D7500, Z50, Z30, ZFC. All these cameras are 20.9 megapixel. 20.9 megapixel. So basically, if you are going to use D850 in a crop sensor, you will get output exactly like D500, D7500, Z50, Z30, ZFC. Same. It's exactly the same. Now imagine you are going to have Canon 50. Let's do this before that. 50 divided by what was it? 2.56 for Canon. So yeah, nearly 20. So if you have 50 megapixel 5ds divided by 2.56, 2.3 for Canon it was 2.56. So this will give you nearly 20 megapixel, which is your 7D, which was 7D Mark II. So that's how it is. That's how exactly it goes. So if you're going to use a crop sensor lens on 5ds, you will get output exactly like 7D Mark II. Sony 61 megapixel, and I'm going to use 2.25 because it's Sony. Sony A7S, no, R, A7R4. So this will give you 26 megapixel. Now Now surprisingly 26 megapixel is offered by Fujifilm in their X-T3 and X-T4 cameras. So X-T3 and X-T4 cameras are exactly have the similar output here of the your Sony A7R4 in crop sensor mode. So if you are going to have Sony A7R4, you using crop sensor lens on Sony A7R4, so you are going to have 26 megapixel, which is exactly like Fujifilm. So Sony A7R4 will automatically behave like crop sensor if you are going to use a crop sensor lens on it. By the way, there is a new rumor I just heard, which is two things, and these two things are the new Fujifilm uh, XT no not XT, sorry, XH2, which comes with non-stat sensor. It has the output of 40 megapixel, and at the same time Sony announced their A7R5, which was 90 plus megapixel. So if I'm going to use 90 megapixel divided by 2.25, it will give me this value. So so the pixel size of the Sony A7R5, which is going to become in future, and Fujifilm XH2, which is going to become 40 megapixel, they are exactly the same. So basically, what is happening is, instead of making a full frame sensor of the same die, because you know once you make the sensor wafer, so the number of pixel size is uniform across a big sensor. What happens during manufacturing of a sensor is that company don't make small sensor. They doesn't make like that. They make a big sensor. All right, big sensor, and out of that big wafer, silicon wafer, and from that silicon wafer they make the lines. So so each of these, this is sensor. So imagine that they cut a little more finer over here. They cut a little more finer over here. So these blue ones, not these ones, these ones, the blue ones, they will become your APS-C or crop sensor, and the remaining in the red will, this will become white, and the red ones, they will become full frame, because the pixel size is uniform across the wafer. By just cutting it, you can make the crop sensor and the full frame sensor. That's how they make the sensor. So if you are seeing the similar output of any full frame camera crop sensor, so assume that they are manufactured under the same pixel size. That's how it is. So the main question which was asked, that if we use a crop sensor lens on full frame, how it's going to behave. So I just explain you in this whole calculation how exactly the if you are going to use any crop sensor lens on full frame, it will project the signal like I just making it, and whatever you are getting in this green, this will exactly equivalent of output that you will get. So the output of that full frame is highly depending on the pixel size, not the lens that you are going to use. Lens has no idea what kind of sensor beneath under it. Yeah, lens has no idea. So it's just projecting the light on the sensor, and based on the projection of light, which I have explained you in this example, on this example, this is where you have to check. The example in which I marked in blue, this is where you have to check that I am using a crop sensor. It will reduce the circle of projection on a full frame lens, so I'm getting the middle portion, only the middle portion. Oh, sorry, this one, only the middle portion of the sensor. Yeah, this is the one. So you are having the same pixel size. So if a 12 megapixel, you're going to get 5 megapixel in crop sensor, but the quality of those 5 megapixel will going to be exactly like 12 megapixel. So if you are using 24 megapixel full frame, you are going to get 10 megapixel in crop sensor lens or crop sensor output, which equivalent exactly behave because it's the same pixel size. You are just only cropping, taking the portion out from that limited circle which is projected by the crop sensor lens. You are not changing anything at the camera level. Nothing is changing. Sensor output is still the same. The SNR firmware is still the same. The analog to digital converter is the same. Everything is the same. You are just digitally cropping the image using a limited circle of projection lens, which is crop sensor lens. I hope I make this point very much clear. Thank you, Imran, for the question. It helped me, making this video, and I hope a lot of you guys learn from this video. And I'll see you guys in some other video with some other new question. Till then, take care.